In this video, we're going to take a look at how to solve one-step equations. So, unlike an expression, an equation does contain an equal sign. Solving an equation is like balancing a scale. Both sides must remain balanced or equal, which means that the equal sign shows what is on the left is equal to or the same as what is on the right side. So let's take a look at this. Steps for solving one-step equations. So the variable must be alone or isolated on one side of the equation. Isolating the variable by using the inverse operations. So addition and subtraction are inverse operations. Multiplication and division are inverse operations. They cancel each other out. Again, the equation must be remain balanced. And then when you're finished, you want to check your answer. Let's take a look at this using algebra tiles. So on the left side, I have an x. So I'm going to put my x here, and then I have one, two, three, four of these. So I'm adding 4 to my x equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this side. So my x plus 4 is going to be the same as my 10. But to figure out what x is, I need to get it by itself. So that means I need to do the inverse or the opposite of adding 4. Opposite or inverse of addition is subtraction. So I would take x plus 4 minus 4 equals 10. And since I subtracted 4 on this side to keep it balanced, I have to subtract 4 on this side, which means x equals 6. And I need to put x equals 6. I cannot just put 6 because x is being represented by 6. So now I can check my answer by using substitution. So I take my 6, put it in for x, plus 4 equals 10. I know 6 plus 4 is 10, and that is the same as 10. So I know that this is my solution for my problem up here, or my equation. Now let's take a look at this one. On this side, I have 1, 2, 3, 4 of these, and that is the same as 1x plus 1. And so again, I want to do the inverse to get my variable by itself. So that means on this side, I'm going to take x plus 1 minus 1 because positive or plus 1 minus 1, they're inverse of each other, cancel each other out. And that's going to equal 4 minus 1. 4 minus 1 is 3 equals x. So now I want to check that. Put 4 equals, and I'm going to substitute 3 in, plus 1. 4 is the same as 3 plus 1, which is 4. So those are the same. So I know that this is my solution for my equation up here. Here's another one. But if you notice, this time we're subtracting because these two are darker, and that represents subtracting 1. So I have my x here, and I have 2 of these, so I'm subtracting 2 equals, I have 1, 2, 3, 4 of these. So now in this equation, I have x minus 2 equals 4. I'm going to do the same thing as I did before. So x minus 2, but this time I'm going to add 2 because that's the inverse of subtraction, equals 4 plus 2. So x equals 4 plus 2 is 6. Now if I back up here and substitute 6 in for x, minus 2 equals 4. Well, 6 minus 2 is 4, which is the same as 4. So I know this is the correct solution for my equation. Again, another problem here with algebra tiles. So I have 1, 2, 3, 4, 5, 6, 7 on this side equals 1x and then minus 1. So again, I want to get my variable by itself. I'm going to take x minus 1 plus 1. And then on this side, I would take 7 plus 1. This side, 7 plus 1 is 8. This side, I would just have x. So right now, my x is equal to 8. And I will check that by putting my 8 in for x. So 7 equals 8 minus 1, and 8 minus 1 is 7. And since they're the same as, then I know this is my correct solution for my equation here. All right, now let's just look at some general equations. So in this first one, I have x plus 5 equals 11. So I need to do the inverse. So I have x plus 5 minus 5 equals 11 minus 5, because I subtracted 5 on this side, need to subtract 5 on this side. So this gives me x equals 11 minus 5 is 6. And then I can check it down here by putting 6 in for x, plus 5 equals 11. 6 plus 5 is 11, and that is the same as 11, so I know this is correct. Over here, I have 15 equals y minus 2. Well, on this side, if I have y minus 2, the inverse would be adding 2. So that means on this side, I need to take 15 plus 2 as well. 15 plus 2 is 17, equals just y by itself. So right now, 17 equals y. If I come down here, 15 equals, substitute in 17, minus 2. So 15 goes 17 minus 2 is also 15. So these two are equal. So that means this is the correct solution for my equation. Here's a couple more. So 17 equals m plus 4. So on this side, I would take m plus 4 minus 4. This side, 17 minus 4. 17 minus 4 is 13 equals m. So I substitute that back in. 17 equals 13 plus 4. 13 plus 4 is 17. That's the same as 17, so this is correct. Here I have n minus 6. So my inverse would be adding 6. I add 6 to both sides. This gives me n. This gives me 18. Substitute my 18 in. 18 minus 6 is 12. That's the same as 12. So I know that this is correct. Okay, so here's a little different setup with our algebra tiles. This time I have 3 groups of x. So I write 3 groups by saying 3 multiplied by x equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I need to do the same thing, but this time I'm doing it with multiplication. The inverse of multiplication is division. So I divide this side by 3. I divide this side by 3. And x is going to equal 4. So again, I'm going to come over to the other side. And I'm going to substitute 4 in. So 3 multiplied by 4, 12. 3 times 4 is 12. That is the same as 12. So I know that this is correct. On this one, I have 1, 2 equals 1, 2, 3, 4. So I have 4 groups of x, so 4 times x. So again, on this side, I'm going to divide by 4. On this side, I'm going to divide by 4. So 2 divided by 4 is the same as 1/2, because 2 is 1/2 of 4. So 1/2 is equal to x. Come over here and substitute the 1/2 in. So I would have 2 equals 4 multiplied by 1/2. Um, 4 multiplied by 1/2 is 2, and that's the same as 2. So I know that this is the correct solution for my equation. Let's take a look at these two equations. First, I have 8x equals 4. So I'm going to take my 8x divided by 8 equals 4 divided by 8. X equals 1/2 because 4 is 1/2 of 8. Put that back into my equation here. So 8 multiplied by 1/2 equals 4. And 4 is the same as 4. So I know that this is my correct solution. Over on this side, I have 12 equals x divided by 4. Well, x divided by 4, the inverse is multiplying by 4. So on this side, that means I have 12 multiplied by 4. So I have over here 48 equals x. And I put that back into my equation. So 12 equals 48 divided by 4. Here I have 12. Here I have 12. So I know that this is my correct solution. Here I have 75 equals 5x. So again, the inverse of multiplication is division. So 5x divided by 5 is the same as taking 75 divided by 5. 75 divided by 5 is 15. And so 15 equals x. I'm going to substitute that back in to my equation. So 75 equals 5 multiplied by 15. 75 equals 75. So I know this is correct. Over here, I have x divided by 4. The inverse of division is multiplication. So I am going to multiply that by 4 equals 7 multiplied by 4. So on this side, it gives me x. On this side, it gives me 28. So then I take my 28 divided by 4, 7. This side is 7. This side is 7. So I know that this is my correct solution.